For covariance and correlation, these are also concepts related to the random variables. So if you want to take two random variables, a pair of random variables, and we want to compute what is the relation between those both, what is the variance between those both, then this is how we do it. We consider, for example, let's consider this height and weight table as a n into 2 matrix, which is like 2 columns and n rows matrix, and then we take each of these values and subtract a mean value from each column, the mean value from each column. That is, if there is the what is the mean value of the height and what is the mean value of the weight, and we subtract each of the height value from the weight value and get another table with the same n by 2, and then we transpose that matrix and multiply to get a 2 by 2 matrix, and then divide each value by the number of values which is there in the number of rows which is there to get a covariance matrix. And this is the covariance matrix of this particular table. So here 7.2 indicates the variance of height, 361 indicates the variance of weight, and the 43.5 is the correlation between both of them. If it's 0, then that means the correlation is none, and that means we'll not be able to determine one value from another. That is, if we have height, we'll not be able to correlate and get what the weight could be, predict the weight. So if we want to predict that, we want this correlation value to be higher, and since here it's 43.5, which is a good correlation value, we will be able to determine one value from another.